If you've viewed other videos on the channel, then you've probably come across the deadly LED toadstool lamp. And what's deadly about it is that it uses a capacitive dropper directly from the mains. And all these lamp holders in series, it's a decorative light, and you can actually unplug the LEDs from the connectors. And if when you're doing so, it basically exposes live connections. It was done as a novelty, but I thought it was time to actually approach this and do a safe version. So let's go over how to do the safe USB powered version. Right, so we're ready to start. We've got the original here, the slightly dodgy one, and we're going to be making one using Molex connectors again. Now, this is my favourite style of connector, the Molex connector. It's actually quite big for this application, but it's got many advantages. For instance, you can crop the LED leads to quite a length to push into it, and it's just very easy to terminate. There are other options for the connectors, though, that are easier to get. Now, the ones I use are, as I said, they're Molex style connectors. They're not actual Molex connectors. The ones I use are from a UK supplier called Rapid Electronics, and they're actually JYK. They're a generic clone. If you're in the UK and you use Rapid Electronics, the stock number for these is 22-0905. But then you also need the crimp terminals that go into them, which come on big, huge reels like this, because they're designed for machine crimping. And their stock number is 22-1098. And then to actually crimp them, you could solder them, but to crimp them, said Clive, struggling to get the sheets apart here, you'd then have to get the proper crimping tool, which is not an original Molex tool. If it was an original Molex tool, it would cost an arm and a leg. It would just be ridiculous. So this is a generic tool, and this one, the stock number is 85-0262. However, there are other options. You can go on eBay and you can buy what are called XH 2.54 connectors. Now, the 2.54 is the distance between the pins in millimeters, and it coincidentally happens to be 1/10 of an inch, because you'll find a lot of this stuff in electronics. The connector pitch is 2.54 millimeters, it's 1/10 of an inch. It's kind of like, it's not 1/16 of an inch or 1/8 of an inch or 1/4 of an inch, half an inch. It's a metric inch. It's just how electronics has always been done. You know, if you look at integrated circuits and the traditional integrated circuits and the sockets, then it's 1/10 of an inch spacing. It's just how it is. However, there's also another option here, apart from these connectors, which I find the XH 2.54, they also do a smaller version. I find these really actually quite hard to terminate, because the distance of the crimp is really tiny. It's really small. I have seen this style connector used in Chinese LED lights, where they've actually had LEDs plugged into these, but having used them, having tried them in solar lights so I could swap the LEDs, I found these really pretty hard to terminate. The other option is the DuPont connector. These are just available 10 a penny, with big bundles of the crimps for just like 1,000 crimps for £3 or $5, whatever, because they've been popularised by Arduino, and as soon as you add Arduino into the mix, it's just mass production central. You can go on eBay and buy these quite cheaply. However, I'm still going to be using the Molex, because I still have to say I find these just a wee bit footery to solder, although they are a good choice. They're much probably easier to get than this Molex style connector. However, I've got thousands of these because I use them in television props and stuff like that, and I've been using them for a long time, and they've become my favourite connector. However, these would be a close second, the DuPont connectors, and I'm going to put these all out of the way now because they're not needed, and neither are the XH connectors. So let's get the deadly one out of the way. You may have noticed at the beginning of the video when I showed you this, there was a slight shimmer as well. That's a downside to the capacitive dropper. Unless you use lots of smoothing, it does have that slight shimmer. This new version will rely on the smoothing of the capacitor inside a USB plug. So the quality of the USB power supply will determine if there's much shimmer or not. In this case, to demonstrate it, I'm going to be using a shitty pink USB charger from China. And this really is, inside it's an abomination. You can see the slight scuff marks because I've had a wee look inside, and this one is not up to any standards. It's not even suitable for Chinese people for safety. It's just one of those little chargers that tries to be a clone of the Apple charger. Now, I think this is an Apple charger. I've not actually had this one open. I really should open it. This one came from 7 Days Shopping, claims to be an Apple charger. I'm feeling a lot more weight in this one. It claims to be a real Apple charger. Maybe I should open that one day. But anyway, this would be super quality. This one is not super quality, but I wouldn't plug a phone into this one. But for something like this, you know, it's going to make it. It's certainly good. It's not going to be any more dangerous than this one. And you know, the LEDs don't give a shit about the regulation of the voltage. As long as it's roughly in the vicinity of 5 volts, and they don't mind if there's a bit of ripple, it's spiky or whatever. So this could be an ideal application for any of these shitty power supplies you have that you wouldn't actually want to plug your phone in. So let's put that out the way as well then. And we'll put this out the way because this is what we're actually going to be working on. I'm going to show you how to make one of these, but there's going to be lots and lots of these in parallel. Because what we're actually doing here, because the LEDs are all going to be basically connected in parallel with a resistor, a 220 ohm resistor, I'll tell you why later. Because they're all connected in parallel for the low 5 volt supply, they're going to have a resistor basically in line with each in LED to limit the current through it. And I chose the 220 ohm resistor because based on the 5 volt supply, if you plug in a red LED, do I have any red? I've got a red LED. This is one of the very red LEDs I'm going to use. If you get a red LED, its typical forward voltage is going to be about 2 volts, which means you're going to be dropping from the 5 volt supply from the USB power supply, you're going to be dropping about 3 volts across this resistor. And with a 220 ohm resistor, dropping 3 volts across it is going to result in about 14 milliamps. I could have gone for 20 milliamps, but as you guys know, I like to underrun the LEDs because, well, they're nicer to look at when they're just run that wee bit lower, and they'll also last a lot longer. But of course, if you're making this yourself, you can adjust the resistor values to suit. The 220 ohm resistor, if you used it with a gallium nitride LED, these are actually colour changing LEDs, but they do contain the gallium nitride chips, the blues, the greens, the whites. If you use it with those, the typical 4 volts is going to be about 3 volts, and if you divide that by the 220 ohms, then you're going to get 9 milliamps. And 9 milliamps might not sound a lot, but in the case of the blues, greens and whites, it's actually ample because they're much brighter visually than the traditional gallium arsenide LEDs. Although the older gallium arsenide technology is actually one of the most robust technologies. Another advantage you're using the 220 ohm resistor is that if the LED shorts out, and we're back to gallium nitride here again, because the gallium nitride LEDs often fail shorted. The thin film technology in them just breaks down and they short out, and initially they'll start flickering, then they can short out completely. And if you get a 220 ohm resistor, this is a standard generic quarter watt resistor. It's a quarter watt carbon film resistor, which is, I quite like the carbon film resistors just because they've got that beigey colour that's quite easy to read the colour code on. But if you have this dead short across 5 volts, then it's going to pass about 23 milliamps and dissipate about 1/10 of a watt, which is, well, you know, it's less than half its power rating anyway, so it's not going to suffer any damage and it's not going to do anything unpleasant. The colour code in this is red, red, brown, gold. The gold is the tolerance, 5%. The red, red, brown is the value of the resistor, 221, which means 22 and then 10, 220 ohms. So let's begin this project. And I'm going to start with these little bits of solid core wire. Now, if you're cutting a lot of identical lengths of wire, I'm going to show you a little trick here. By getting some solid core wire, and if you make a couple of marks and you get a pair of snips, you can cut. Say for instance, let's make a couple of marks here on my bench, but I'd normally do something like this. Well, let's actually do it the same length. I'd normally do this from the edge of a table. This is something I learned to do while I was making my Fairground light controllers and had to make lots of little tiny tails of wire because I didn't like running a lot of current through PCB tracks. So if I then get a pair of snips, he said, hunting for his snips, which are here, industrially grade snips, and you put it across like that, and then you grip the wire at the this mark down here and move it up there to the second mark and then cut down to the bottom, grip, cut. You can cut lots of these very quickly. Literally, when I was at the peak of manufacturing, I was going clip, 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 and it was that fast, cutting them all exactly the same length. So that's useful to know. However, we'll need one of these. Well, we actually need lots of these. This is one of these projects that it's quite, you don't have to do it all in one night. It would take a modest length of time because it does involve lots and lots of bits of wire and LEDs and solder joints. But let's start but you can spread it out over the time, you don't have to do it all at once. It's just one of these therapeutic projects that, it's the sort of thing that if you're making it for yourself, yes, that's fun. If you accidentally promised a friend you'd make a version with 100 LEDs, then you could probably regret that. It would be quite a time-consuming task. So I'm going to start by just stripping about 4mm, which is just over an 1/8 of an inch. It's somewhere, I guess that's 5/16 is probably the closest inchy type measurements. And I'm going to do that in both these red leads because I'm going to be putting the resistor dead centre. And unlike other videos where I usually get all ambidextrous with the fingers, I'm going to be using, oh excuse me, I'm going to be using a set of helping hands. Oh, incidentally, tonight's alcoholic beverage of choice is Diet Pepsi with gold-flecked moonshine. Yes, eat your heart out, Queenie. This is the home of decadence. There's no real point in this. It looks very nice, the Diet Pepsi with the gold floating in it, and it kind of, because it's carbonated, it seems to float up and down. It's just, basically it's what I had left after a recent test project. And it is genuine gold. I say it's genuine gold leaf. It came from eBay, so it could, maybe it's yellow lead. But anyway, it's interesting. That's better. So we've got the resistor here, and I'm going to be using the helping hand because it does, in this instance, make it a lot easier. And I could crop the lead down to about 6mm or 1/4 of an inch on one of the ends of the resistor. And I'm going to pop it into the helping hands just to hold it steady. And I'm going to get my generic Chinese soldering iron. This is a Yihua 8786D soldering station I'm using. And the reason I'm using this soldering station is because it also has a hot air gun, which is also very useful for this project because it uses heat shrink. And this is just a fantastic little station. The hot air gun is just worth its weight in gold, just purely for doing heat shrink. So what I'm going to do is I'm going to tin the lead of the resistor. I'm going to put a little blob of solder on it, and I'm also going to put a blob of solder on this lead, as the red lead, because I'm putting the resistor in the middle of the positive lead. And normally I would just say, yeah, just when you've done this, normally just hold them together, reflow the solder, fine. But in this instance, for extra neatness and extra quality, I'm going to actually suggest using flux. Now the flux I'm using is just whatever came to hand, as often happens, and it turned out to be just standard. This is flux designed for soldering pipework together, copper pipework. And bizarrely, I was thinking, I wonder where this is made, and I looked in it and it says, made in the USA. Made in America? Really? That's surprising. So here's the flux, and what we're going to do is I've already tinned this lead. I'm just going to dip it in the flux, just put a tiny quantity on, and the reason for this is that the flux will ensure the solder flows. If I didn't use the flux and I reflow these together, there's a risk that if all the flux was completely gone from the previous soldering processes, then I might draw a slight peak. And the slight peak that comes off from the sort of dryish solder results in a sharp point that can poke through the heat shrink, and I'm wanting a fairly smooth joint. And this is ultimately going to result in a much better flowing of solder as well. So I'm going to hold these, I'm going to actually put my finger under the vise here and support this, get them right close together, and then flow them. And Another thing worth noting, did you see the hiss there? Did you hear the hiss, should I say, in the little cloud of vapour? That was the flux. The flux, the point of the flux is that it's going to actually help mate the surfaces together. It's going to clean the oxides off and mate the solder onto the lead. The other thing I meant to mention is that don't push the lead right up hard against the resistor of the body of the resistor. You want to keep it a few millimetres, maybe about a 1/16 of an inch to an 1/8 of an inch away from the resistor, because although this results in a much longer sort of connection here, it means that if you're bending leads and twisting them about, you're not going to have that situation that it's going to lever and put a lot of pressure against the end of the resistor and potentially damage it. So now I'm going to turn it around and I'm going to grip it in the helping hands again, and I'm going to flow solder onto the other side of the resistor. And that has left a bit of a peak there. But that's okay because I'm going to be using the flux again. So I'm going to dip this in the flux, just tiny quantity. You don't want to scoop big handfuls of flux. And you just want to sort of wet it with the flux to help flow the joint. And then position it again with the wire not touching the resistor body, and then flow that. Sweet. Nice, clean, shiny joint with no peaks. Lovely. And a strange smell of potato fries for some reason. Yes, I know this is from America, but yeah, really it smells like chips. That's interesting. It smells quite nice actually. It doesn't smell chemically, it does actually smell like I've just fried up a large portion of potato fries. So that's the resistor now in line with the positive lead, and I'm going to get a bit of heat shrink, and this is where you can choose between black heat shrink or clear heat shrink. Now hold on, I'm just going to check the size of this. The heat shrink I'm using is 2.4mm heat shrink, which is roughly 1/10 of an inch heat shrink. Okay, you could probably use, I'm not sure, in America, is sizing done in inches for the heat shrink? I'm not sure. But anyway, this one is, because we're in Britain and everything's supposed to be European, it's 2.4mm heat shrink. And I've got the choice of using clear or black. I'm going to use clear because I've got nothing to hide here. And I kind of think it looks quite nice when you can see the resistor inside. I'm going to slip it over that. I'm cutting it to size. Ironically, it's about 1 inch long, 25mm. But you just size it to whatever you actually end up with the distance you've cut the leads. I'm going to grab the heat gun. It's a very quiet heat gun, it's nice. And this is currently set, the heat gun is set for 200 degrees Celsius, or centigrade, whichever you wish. And I'm just going to run it over this heat shrink and shrink it on. And the point of that is it's going to stop the resistors from shorting against each other, and it's going to protect it from contact. And it looks quite nice too. Job done. So now I'm going to get the black lead as well, and I'm using solid core wire here because I want them to hold their shape. I'm going to twist them in the end, and I want them to actually hold their position with the LEDs and sockets in the end. If it was stranded wire, there's a risk it would be too floppy. And I'm going to actually put the crimps in the end. Now, this is where you have an option. You can either get the super expensive crimping tool, like I have, and I got one of these because this isn't the original Molex one. The Molex one was just unaffordable. It's like these big manufacturers just say, let's exclude all the hobbyists by making our tools only available to big industry. Don't get that at all. Microchip were one of the first to really break that mold. They made their development systems for the microcontrollers available to hobbyists, and I think that paid off rather handsomely. Anyway, this is a clone tool. It's a generic Chinese tool, and it's got the ratchet mechanism in it. And the point of the ratchet mechanism is when you squeeze it shut, you can't stop halfway. You have to go all the way till it's finally clicked before it will open again. And the point of that is it stops people being half-assed with a crimp and just going, and then taking it out and it's not crimped properly. So you've got the option of using a crimping tool if you have one, or you know, it's not like a standard terminal crimp. It is optically, it is specifically optimized for this type of crimp. It's designed to actually not just grip the wire, but it's designed to actually fold the strain relief around the cable, the plastic, the insulation of the cable. But if you can't, if you don't have access to one of these, you can also put these crimps into the helping hands here and grip it, but actually angle it down the way and then solder wire in. The reason for angling it down the way from the actual contact area is you don't want the solder to wick up and flow into that. You want it to actually, you want gravity to keep the solder away from that. So angle it down the way and put a touch of solder in, put a solder on your wire, lay it in and flow the solder. But I'm going to be using the crimping tool because I'm cheating, because I've got my big posh tool here. So I'm going to lay the terminal in. This is where a totally automated machine would have been very nice. I'm going to strip about 3 or 4 millimeters from the end here, 1/8 of an inch to 5/16 of an inch, I guess. I'm going to sit that into that terminal, and this is where I'm completely doing the, you know, there are specific exact measurements you're supposed to use, but, you know, I don't care actually. As long as I have a good connection, that's fine. And I'm going to press that in. I'm also going to just slide the insulation in just into the bit that grips the insulation and crimp it, and that's me got a good solid connection. I'm going to do the same with the black wire, the negative. You don't have to use red and black, you can use anything you want. Just remember to keep one polarity and one the other, just for ease of making this. So I'm putting the second crimp in here, running it up to the end, gripping it and putting this in. And this is where I may actually have just slightly over crimped that already. Sometimes you grip it too tightly. I think I've done it already. I'll actually partially crimp that. Okay, glad I've got a spare terminal. So let's pop this one in and see if I can not do that again. That's better. It took me a while, once I got this crimp tool, to get absolutely into the swing of it, but once you get familiar with it, it's actually really easy to use, and you can get through quite a lot of crimps in a very short time. It's a good tool. One of the more expensive tools for a sort of hobbyist, but you know, it's fine. Now, the Molex connector, I've already made a mark. You can choose which of these connectors, which side you want to be negative and which is positive. These generally have a 1 marked on them, depending on the, you know, well, all the connectors, from 2-way to 13, 14, 15 way, they all have a 1 marked at one end. And I just choose that as the positive. I don't know, other people would maybe choose that as a negative. I choose the positive, and then you slip your connection in and it latches. Basically there's a little tongue that sticks up from the top of the connector, and there's a little slot here, and you can slide it in and it latches. And if you make a mistake and slide it into the wrong place, by using a bit of pressure against the wire and pushing a screwdriver in there, you can actually release the connector too. But I have marked the side that's negative. I've actually put I've got a Sharpie and just run it across one end, and I've done that to, well, you'll see when I bring the others in, I've done that to all the others as well. I'm not going to show you doing every single one, because this light is going to have 16 of these, and that would take a very long time, because you've already noticed how long it took to do this one. It's it's one of these things that, you know, it's just therapeutic. You just plod away, and it takes hours, but you end up with a really nice thing at the end. So now I've got this resistor in series. I got the LED socket at the end. I'm going to crop the leads to the exact same length. They're pretty much the exact same length already. And I'm going to strip them to join lots of them together. And this is where I'm going to strip them. I'm going to be generous. I'm going to be doing it almost 25mm, almost an inch. Purely because if you leave them too small and then you try twisting them together, then they all start popping apart again. It just makes it easier if you're generous, because you can cut off the excess, but if you get too little, it just causes lots of problems. So this is where I bring in all the ones I've done already. technically speaking, now I've done this one as well, I should just add it into the mix. And I'm going to start twisting these together. Now this is where it would actually, in many ways, it'd be quite nice to get a bit of cardboard or something and sit it in between them so the negatives are one side and the positives on the other. In fact, you know what? I'm going to do that because I think that would make things a lot easier. I'll be back in a moment. Yes, the cardboard definitely helps, but what also helps is actually break it down to smaller bite-sized portions. So I've got groups. I've got a group of 6 here, 6 here. I've got 5 left. So I'm just going to slide these over this bit of cardboard, which has a picture of a 20-watt LED floodlight case on the other side. So that's a surprise. And I'm just going to slip these leads over with the positive on one side and the negative on the other. And this really does help keep the wires from tangling off. It makes it a lot easier for actually terminating it. So I'm going to put them together like that. And just pull them all down to the same position and twist the ends together. It's just so much easier doing it in little bite-sized portions than trying to do the whole lot together, because otherwise you can end up with just it gets a wee bit cluttered. It's easier this way, that's all I can say. So that's those twisted together, and now that we've got those done, we can then take all the positives and keep the negatives at the other side, and we can twist the 3 clumps of positives together. Turns into quite a large congealed lump of metal. You may have to use a pair of pliers to help twist these together. And I'm going to flow some solder onto these. This is where I could do some thicker solder. One moment. Thicker solder. And this is where I need a soldering iron with huge thermal mass. Uh-oh. But this will work. It will just gradually heat it up. Am I going to regret this? Yeah, it's going to take a while to heat that mass of leads up, but the solder will eventually flow into them. How's that looking? Is it right through to the other side? It is, but let's heat the other side and flow some solder in that as well. It is quite a large clump of wires. Ah, that's better. Can see the solder. That'll actually take a wee while to cool down now. So I'm not going to move it too much until it's cooled. That's cooled. Oh look, they are actually separating. This is why it's better to actually do it in small bunches. The first time I tried something like this, I did do them all together in one huge bunch, and it was just too much. It's very easy to get all the positive and negatives all just intermixed, and then, you know, if they get too twisted together you can't separate them properly afterwards. So let's solder this one now. Forgetting another technique I used was just to wrap solder around it from all directions in a spiral, and then just flow that on. Oh, yeah, I'm making a dog's dinner with this, but that's okay. Okay, looking pretty good. I'll just flow some solder from the other side as well. This is where a higher mass iron would be quite useful, but you know what? Make do with what you got. This also alludes to the fact I should be doing some experiments with this soldering iron with regards to thermal coupling between the heating element, because that's one of the biggest weaknesses of these generic Chinese soldering irons, is the thermal coupling between the internal heating element and the bit. Right, okay, let's sweep all the evidence of bad soldering out of the way onto the floor where it can be vacuumed up later on. Right, so now we have the huge chunky mass solder joints and all the sort of tails. Now what I'm going to do is I'm going to actually twist these. Now this is where you have to be quite careful, because if you twist them and you twist them too tightly, you risk, particularly if the soldering's a wee bit shady on your resistors, you risk actually snapping the solder connections off the resistor. So just be careful about it when you're doing it, and just don't twist them too much. The reason we're doing this is to keep them as separate tails for the end result, because each one is going to be basically a stem of a toadstool plant. If that's even a thing, I'm not sure. Is a toadstool plant even a thing? It's not really a plant, is it? It's a fungi type thing, but I've got weird things planned for this. It's not just going to be a toadstool. It's going to be a very odd light. Oh, look at the way that resistor's spiraled round. That's probably not a good thing, but that's fine. It's better. This is another thing that I like about the Molex connectors. They really hold. The crimps really latch into the Molex type connector, so they can take that abuse of being twisted like this, particularly with solid core wire. Technically speaking, solid core wire isn't ideal for going into crimps, but the Molex ones, I've made quite a few lights like this. I mean, the whole house is just full of random lights, and a lot of them are using this sort of arrangement, and they've been fine. Ideally, with the crimp connectors, you'd be using stranded wire, but having said that, stranded wire isn't rigid enough to actually support. In this case, we're looking for the solid core wire to actually support the shape of the light. Now, this is where if you tried to do them all in one big clump, this is what would have happened, as what has happened here, that they're a wee bit interwoven with each other, so it kind of spoils the sort of separation between the individual leads. But that's okay. Every lamp has its own character. Everyone's a one-off. Okay. Right, now we need the power supply, which is going to be a USB lead, and here conveniently is a USB lead from Poundland, but you can get one from anywhere. This is apparently improved quality. I'm really excited about that. He lied. I'm not sure exactly what improved quality means. Purple, specifically chosen just because, you know, well, purple. And what we're going to do here is we're going to cut the end off. We're going to cut this plug off, and we're going to strip it back. And inside I'm expecting to see a red lead, hopefully, and a black lead, and then the data pair. Now the data pair aren't really important to this application, and we'll just be cutting them back. So we've got pink, grey, green and white. Well, that's really helpful. Pink and grey, I guess, are positive and negative. That's not terribly helpful at all. Let's strip them, plug it into a USB power supply, and see what we get in these leads. Are they copper? Yes, they're copper. That's nice. That's a good start. I'm guessing white and green are data, so we'll just keep them at the side at the moment, and I'll bring down the little pink USB power supply, and making sure I don't short the ends of these, I shall plug it into that. And I'll get a meter, and I shall turn that to the 20 volt range, and we'll stick the positive lead on the pink, and we'll stick the negative lead on the black. That looks good to me. 5 volts. It's not showing the negative 5 volts, which means it's correct polarity. So grey is negative and pink is positive. Right, that's useful to know. Every lead, every USB lead is different. Sometimes you get them with really vivid red and black, and red's negative and black's positive. You really have to check the meter. So I'm going to cut the data leads off. I'm going to cut them. I'm going to cut one flush, but I'm going to cut the other one just a little bit higher than that, just so they don't short out. I may even put a bit of heat shrink sleeving across that. That would be a good idea, wouldn't it? To shield those, I'm just going to go and grab a bit of heat shrink sleeving right now. So which size is going to fit? I think the 2.4mm is going to be a wee bit too small, so I'm going to use a piece of the 3.2mm. So I'm going to thread that over those two leads. And all this is doing really, it's just covering those data leads, because we don't want the data connections exposed, particularly if you plug it into something like a computer. because you could plug this into a computer, because it's not going to draw that much current. So I'm going to put that heat shrink on. It sort of caps the end of that cable off nicely, actually. Job done. And then I'm going to strip these just a little bit longer so I can get a good wrap around the base of here. And then the negative is going to wrap rather predictably around the blacks, the negatives. And this is where we have that heat mass issue again. Oh, it's not too bad. Let's make sure I get a decent connection though, without melting all the insulation. I should move this out of the way so I don't splash hot solder into it. Looks pretty good, so that's one done. I'll just pause momentarily to sink lots of heat into that so it all flows nicely. Okay, and now I shall go over to the other side with the positive and do exactly the same thing. So I'm going to twist those together, wrap it round. This is another advantage of actually stripping a modest length, because if you're applying, because these are quite high thermal mass joints, the cable's going to get hot, and if you kept it too close, there's a risk that you're going to melt, the heat's going to travel back along the copper and melt between the insulation and the cable. So by keeping the cores just that little bit longer, that's going to reduce that risk. The same applies to terminating things like audio connectors. If you try to get too clever, if you try to be too close with the stripping the insulation back, and when you're soldering connections into audio connectors, you can sometimes end up, the insulation melts a little bit inside, and you end up with copper-to-copper contact, you end up with a shorted connector, which is never good. All part of the learning experience. That's looking pretty damn good. Right. So now I'm going to get my big schnapps. I'm going to crop that down a bit, and I'm actually thinking it'd be quite good. Oh, that is quite a chunky mass of copper. It'd be quite good to actually put a bit of heat shrink sleeving over these too. So I'm going to do that. I'm going to grab the next size up again. So let's see, here's 4.8mm and 6.4. Is this going to fit? It's a bit in the borderline, so we'll go for the thicker stuff. The advantage of using the thicker stuff is that as it shrinks, it sort of gets thicker and it provides extra insulation. If you use something that's just a wee bit too close to the actual size required, it can sometimes just end up really stretching quite thin when it shrinks. So we'll slip that one over there and that one over there and shrink them down. Heat shrink's great stuff, yeah. Really, it's definitely a must-have for the typical electronics workshop. It's not that expensive, again, thanks to the wonders of eBay. I get my heat shrink from Rapid Electronics in the UK, which is, I get most of my serious electronic components from Rapid Electronics. I'm quite happy to use eBay stuff for sort of hobby, fun type things, but serious bread and butter electronics, I tend to use electronic suppliers. And for the really hardcore components that are mission critical, I'll even use RS Components, because they're like the Rolls Royce of suppliers in the UK. Right, this is looking good so far. Let's start plugging LEDs into it. I'll just clear these out of the way. The hot air pen just runs on for a little bit longer after you've used it. When you sit it back in its cradle, it starts just running the temperature down, but the fan keeps running just to help cool it down, and then it cuts out. So I'll just clear off the bench here and we can start loading this up with toadstools and stuff. But first some gold-laced Diet Pepsi. Nice. Right, now here's another advantage of using the low voltage USB power supply. Because with the mains version, you could only power it up really after you'd plugged all the lights in because they were all in series. With this one, I can plug it straight in. Let's put a current monitor in this as well, that'd be quite interesting. So now I can bring in the LEDs, and I'm going to put in just random LEDs. This is going to be very random, so I'm going to put in a red LED. Now the negative is the short lead. The LEDs I've pre-cut slightly. Because with a normal LED the positive is the long lead and the negative is the short, there's a slight length difference. I like to trim them down for going into these connectors. Whatever connector you use, just trim it to the appropriate length. But I like to leave the positive just that little bit longer as a marker. So the black is the negative, so the positive goes into the non-black one, and voila, the LED is lit. So I'm going to start just randomly scattering some of these LEDs in here. So there's an orange one. I like the 10mm diffused LEDs. They're a nice LED. A wee bit harder to get. You can get them on eBay. Just type... the best thing to do when you're looking for LEDs on eBay is type 100 PCS, 100 pieces, or 1000 pieces, and you'll find the bulk suppliers. If you type in just 10mm diffused LEDs, you'll find local suppliers who are clearly just buying stuff from China on eBay and then marking it up significantly. So if you go for the bulk suppliers, you get much better prices. What's the current standing at the moment? Current is currently standing at 90 milliamps, which is nothing. So let's stick some more of these in. Now let's get the magic toadstools in, because we want toadstools. So here's one of these little toadstool night lights, and I'm just going to pull the caps off. You know, it's annoying that these used to come with little sockets in the end, the little XH type sockets, and you could just plug the LEDs in, but they've stopped that now. I'm guessing that was either because people, when they pulled the covers off, were getting the LEDs in the wrong way around and blowing them up because like it's quite a high open circuit voltage, or the capacitor was smoky inside when they pulled them out because the voltage floated up too high, or it was maybe just a safety thing. I don't know. It seems a shame though. These are colour changing LEDs. Let me demonstrate. If I plug this one in here, it starts off red, then it goes green, and then it goes blue, and these are what are called slow. If you do a search for diffused, because I prefer the diffused ones, diffused 5mm RGB slow, those are sort of keywords that are going to find these colour changing LEDs. So there's one colour changing mushroom. Let's plug another colour changing LED into a random location in this cluster. And let's put a mushroom cap over that. And then another colour changing LED, because this is just going to be completely just everything and going in this light. Keep in mind that because you're making this yourself, you can do anything you like, and the more random and weird you make it, the less like there is ever of anyone in the world ever having one that even looks remotely like it. So that's 4 colour changing mushrooms, all just randomly going through colours themselves. Yeah, that's pretty good. Then let's add some other stuff into the mix. Here's a red flower. It's a mushroom, a toadstool flower. I'm not sure if such things exist, but they do now. Here's a yellow one, which is a kind of orangey yellow LED. And a blue flower, because blue flowers do exist in nature probably. Yeah, they do actually. Kind of hard to find though, proper blue flowers. Oh, that's looking good. That's looking very psychedelic. How many sockets do I have? I've got a few more sockets left here. Let's part those sockets out to the side. I've got some leaves here. So stick random green leaves in. Oh yeah, that's quite nice. And of course, because the LEDs plug in, if you change your mind, you can just swap and change. You can just patch about. So I've got one more LED position. I quite like the orange LEDs, they're quite nice. Right, so yeah, I could have done with spacing the leaves apart a little bit. There we go. We can just shuffle them about like that. This is just definitely looking a bit weird. That's good. It's always good when stuff looks a bit weird and outlandish. Right, so current consumption is a measly 20 milliamps. 200 milliamps. So that's going to easily run. Now, this is a cheap, shitty power supply. This is one of these little death adapters type power supplies that's just not really compliant. But it will be absolutely fine for running something like this. Because the LEDs just aren't really going to be too phased if the voltage is just a wee bit too high or a bit too low, and it doesn't matter if there's electrical noise on the supply. They're going to be just fine. So now all I have to do is think, what am I going to pot this into, because it needs to be put into a little base to hold it up. So I'm going to have to hunt around for a suitable base and maybe pot it in with resin. So I'll be back shortly. Perfect. It's a glass candle holder that is just absolutely going to look so great. It's heavy, so it's going to hold the base. It's going to actually weight it down, and there's plenty of room to resin the tails of the lights into it. So I've got some 2-part resin, Poundland 2-part resin, as always. And then I thought, well, you know, I might as well just go too far. I mean, this project is all about overindulgence, so I've got some of that rare earth glow-in-the-dark powder. So I'm going to add that into the mix too. So I'm going to squirt this, I'm going to squirt the whole lot of this resin in here. I'm not going to need it all, I don't think. Maybe I will, I don't know. And I'm going to mix that in with the rare earth powder. I'm just going to put a wee scoop of that in. Just a modest amount. It's just going to make it glow in the dark slightly, even when it's off. And then I'm going to put the cap in that again before I make a huge mess. Not that making a huge mess is anything really bad. It's just no such thing as a bad mess, really. Well, there is actually, but when it's an electronic-y sort of mess, it's fine. Stuff happens. So I'm going to thoroughly mix the 2 parts of the resin together. 2-part resin is my favourite glue, because it's, you know, if it's the stuff that sets in 5 minutes, it's just perfect for impatient people, basically. Super glue has its place, but it's not really ideal. This is ideal for making stuff that's going to be potted, or, you know, you can pot things or just glue things. It's very versatile. So I'm going to pour some of this, now it's mixed, into the centre of the glass star. And I'm going to try and work out how much I need. If I get enough here, I think I've got enough. Yeah, I think I've barely got enough here. I want to actually fill it up to the point that I can scrape. I was actually hoping to have too much, but I don't think I'm going to have too much. I was going to create another little thermonuclear spill if I had. One of those things where you just tip the container over and let all the glow-in-the-dark pigment saturated resin flow out, and then it looks like a radioactive spill. If you watch my videos, you've seen what I've done in the past. But I don't think I'm going to have enough for that. No. Kind of set the place up for it as well. I'd actually put some clear tape on my bench here to allow for that, but I don't think I'm going to have enough to actually do that properly. That's a shame. Not to worry. What I would have done if there had been tons left, I would have just tipped it over, and then it would have spilled out onto this clear plastic, and then I'd have been able to peel it off afterwards, and it would have looked like a little sort of radioactive spill. But you can see that it's featured elsewhere on my channel. So now I'm going to sit this in, and the resin will flow between all the bits and pieces. And then comes the boring bit. I have to actually just stand here and hold this until it sets, which is extremely tedious, but it's only going to take about 5 minutes, but that 5 minutes will seem like forever. So I'm just going to pause momentarily so you don't have to suffer that eternal wait. Well, that turned out hideously well. This is just a wondrous abomination. It's fantastic. I should add that the resin's set very quickly because it's very warm at the moment. It's about probably 20 degrees Celsius in here, which is quite hot for this sort of area. So the resin's set quickly, and Suddenly I remembered I meant to add things. I meant to add a bit of foliage, so I had to actually let the resin set and then drill it to actually add these things. But I also added these little wires, and the wires, since, you know, this is toadstools are associated with fairies, and since I had this, remember this Moonlight Monsters with the sort of fluorescent Lego with all the bizarre number of handbags, I decided to add, in fact, Moonlight Monsters, here we are, here's the base of the thing with all its flashing lights. I decided to add little support wires with handbags hanging from them, just because that's just so twee, it's absolutely hideous. So yes, it's actually got little plastic handbags hanging from it as well. It's, yes, it's odd. So let's take a look at it in the dark and see how it looks. I really like the glass star, it really weighs it down. So let's take a look in the dark. Oh yes, particularly loving the glass star base at the bottom here. It's very heavy and it holds in place. It's a fairly standard sort of candle holder, and I suppose ultimately candle holders are ideal for this as a weighted base with a hole that you can pour resin in. This looks fantastic just because it's so utterly random, and that's the beauty about making something like this yourself. Just anything goes, absolutely anything, and the more weird you make it, the more unique it is. The simple fact is that nobody else will ever have an identical light. It's completely 100% yours. So good result, but I made a mistake while I was making this video, and it's a mistake I've made in the past, most notably when I was doing this project for my website just ages ago, like decades ago. I mean, the reason the picture's so low resolution and small is because this was the dial-up internet era. It was a long time ago. But I made this LED tree, and it used 128 flowers, and if you consider it was all etched and drilled by hand, it was 2,816 hand-drilled holes, 1,152 LEDs, 256 resistors, and about 200 meters of cable. And it was one of those projects, you start it and then you think, oh dear, yeah, and I had to take a break from it a couple of times and then go back to it because it was just too much to do in once. But back then, when I twisted the wires together, and you know where I'm going here, I had that problem with the heat issue, and back then I was using the Antex, even though it's quite a big chunky iron, it's got the big bit to it. It was also having that issue that if you twisted too big a clump of wires, then when you tried soldering them, the heat dissipation along this big chunk of copper was just too fast, and it meant that, you know, it took the heat away and it was difficult to solder. And the solution I used then, which I should have used now, was to keep it in small bunches of a maximum of 6, like this. And even with the little Yihua Chinese soldering iron, once you've sunk some heat into the copper, so do that right now. Once you've sunk some heat in, that's well within its capability. The solder flows right along and goes into all the strands nicely. And what I did back in the Techno Bonsai era was I then got these bunches and I simply put another wrap. This is red hot now. I put far too much solder in that. I took another wire and just wrapped it round, and then went on to the next bunch and wrapped round, and then soldered them, and then got more wire and just wound them all together in a big clump to create a good solid connection between them all. Another option is ultimately you could use terminal block. You could actually pre-solder them into sort of solid chunks and then put them into a common terminal block. Or, given that it's very low current, you could just bind them with the copper wire into a group and not solder them at all, though to be honest I prefer the idea of soldering them. But that would have made things a lot easier than trying to solder all these wires together at once. Now, on the subject of this is currently running off one of these little generic, you know, Chinese power supplies, and the LEDs, they're not bothered by any sort of noisy power supplies or, you know, slightly off voltages plus or minus a volt. So you can use just a basic cheap, if you've got one of these cheap power supplies that you really don't want to take the risk of using your luxurious phone with, then, you know, this is maybe an ideal application. And when it blows up, it's not going to be the end of the world, because like at the worst, if it put out rogue voltage, you could just unplug and plug in new LEDs. It's fairly indestructible. The power consumption of this is just minuscule. It's about a watt. So you don't even need to turn it off at night. You could leave it on all the time if you want. I've got a different version of this that I gave to my brother, and he leaves it out in the sort of landing upstairs where, you know, my mum's bedroom is as well, and it's an all sort of orange plant, and it just gives this lovely orange glow, and it's just lit 24/7. You can run it off a USB power bank, but keep this in mind. The simple USB power banks, when the battery runs low, they turn off the boost converter, and that's basically, they don't isolate the cell completely. And some of these LEDs are able to run down to about 2 volts. So even the boost converter off, current will still flow. They'll be dimmer, but current will still flow, and there's a potential to over discharge the battery. So I wouldn't recommend running them for very long periods, you know, just walk away and forget it with one of these power banks connected. The higher profile power banks, yeah, the ones that actually physically disconnect the cell inside, they'd be alright. But having said that, you know, if you've got an old phone charger that you know, used for a phone that you don't really use much anymore, and the charger isn't really capable of charging your modern phone because it's quite power hungry, then this is perhaps an ideal application for it. The other thing, as I've already mentioned several times, I thought this star candle holder worked out really well. And what comes to mind afterwards, now this one that I filled with the Dayglow, the light absorbing, the sort of glow in the dark type pigment, non-radioactive, it's just it's like a phosphor that absorbs light during the day and gives it off in the dark. But that looks really nice when it's dark. When you turn the lights off, the glass really looks sort of shiny and iridescent. It's quite nice. But you could put an LED down in there with the resin, with its own resistor, and just have the base glow. I would choose, given the reliability of the gallium nitride LEDs, the blues, greens and whites, not being as good as the reds, oranges and yellows, the older technology, I would probably choose something like red, orange or yellow for down there to just make it so, you know, because you wouldn't be able to change the LED if it was actually embedded in the resin. But yeah, it's been nice. It's worked out nice. It's weird. It's just very customizable. So yeah, the little LED like safe, the safer version of the LED toadstool lamp.